Hello everyone, in this video let's go through the area of parallelogram and triangle using trigonometric ratios. So this is the parallelogram and we know the area of the parallelogram is given by base times height. So this side length is the base here denoted by b, while this dashed line denoted by h is the height here. But what if the height of this parallelogram is not given and instead the side length a, b and then the one of the internal angle of the parallelogram is given? In such cases, you can still find the area of this parallelogram using trig ratio. So you see here, this height of this parallelogram is forming a right triangle with this portion of this parallelogram. And let's say the angle formed here is theta. So with respect to this theta, the side length h, that is height, becomes opposite. And then the longest side of this right triangle is a, which is hypotenuse. Since it involves opposite and hypotenuse, so let's use the sine ratio, which says sine theta is given by opposite over hypotenuse. So sine of angle here is theta, and then the opposite with respect to this angle theta is height here, and then the hypotenuse is side length a. There is a denominator of 1 to the sine theta. Now cross multiply this proportion, which becomes 1 times h equals to a times sine theta, which gives us h equals a sine theta. Now substitute this value of h equals a sine theta in this formula, which becomes a equals to b times h means a sine theta, which equals ab sine theta. So this formula gives the area of a parallelogram when the height of the parallelogram is not given. Now let's see how to find the area of this triangle if the height of this triangle is not given. We know that area of the parallelogram is given by AB sine theta. So to find the area of this triangle, it will just be divided by 2. Divided by 2 because all triangles are exactly half of the parallelogram. So this formula gives the area of a triangle if height is not given, but instead we are given the two side lengths A and B and then any of the internal angles of a triangle. Now let's look at this problem which says find the area of the parallelogram given below. Since the height of this parallelogram is not given, so let's use the formula which says area equals AB sine theta. So substitute the values here. A here is 10 centimeter times B here is 20 centimeter times sine of angle here is 30 degree, which equals 100 centimeter square. So the area of this parallelogram is 100 centimeter square. Let's look at the next problem which says find the area of the triangle given below. Since the height of this triangle is not given, but instead we are given the two side lengths A and B and then one of the internal angle. So let's use the formula which says AB sine theta divided by 2. Substitute everything in the formula. A here is 10 centimeter, B is 15 centimeter times sine of 45 degree, which equals 106 centimeter square. So the area of this triangle equals 106 centimeter. Let's look at another problem which says find the area of the trapezoid given below. Since this trapezoid comprises of parallelogram and a triangle, so first let's find the area of each shape, that is area of parallelogram and a triangle, and then add it together to obtain the area of this whole shape, that is trapezoid. So area of parallelogram denoted by a subscript p given by AB sine theta. Substitute the values here. So in this parallelogram, A is 10 unit and B is 25 unit times sine of angle here is 40 degree, which gives us 160.7 square units. Now let's find the area of the triangle denoted by A subscript T, which is AB sine theta divided by 2. So in this triangle, the side length the 10 is B, while this side length is A, which equals 10, and then the angle here is 40 degree. Substitute in the formula. A here is 10, B also equals 10, and then angle here is sine of 40 degree divided by 2, which gives us 32 square units. So now add the area of parallelogram and area of triangle to obtain the area of this trapezoid. So area of trapezoid is given by area of parallelogram, which is 160.7 plus area of trapezoid, which is 32, which gives us 192.7 square units. So the area of this shape is 192.7 square units. Now let's look at this last problem which says find the area of the rhombus with side lengths of 20 centimeter and an angle of 60 and 120 degree. So let's draw a rough picture of what the problem is asking. So this is the rhombus with side lengths of 20 centimeter and the acute angle here is 60 degree, while the obtuse angle here is 120 degree. Since all the side lengths of a rhombus are equal, so all the side lengths will be 20 centimeters. So this side length also equals 20 centimeter. Since rhombus is a special parallelogram with all side lengths equal, so let's use the formula for area of parallelogram, which is AB sine theta. So substitute everything here. A equals 20 centimeter, B equals 20 centimeter, and you can use any of these two angles, sine 60 or sine 120 degree, because sine 60 degrees literally equals to sine 120 degree. So I can either use sine 60 degree or 120 degree, which gives us 346.4 centimeters square. So instead of the sine 60, I can also use here sine 120 degree, which would still give us 346.4 centimeters square. So the area of this rhombus is 346.4 centimeter. I hope this video is helpful and thank you for watching.